Now let's have a closer look at what exactly happens when a molecule absorbs light. So we know that the interaction between different molecules and light will lead to the excitation of electrons from a ground state to an excited state. So the ground state is called S naught, so we call it S naught. And there are two different excited states. The first excited state happens which is called the singlet excited state, and it's called S1, will happen when the electron is excited to a different excited to an excited state with opposite spin. So this molecule in the ground state was spinning in this direction, and now it's spinning in the opposite direction. So this is called the singlet excited state, and we call this S1. There's another excited state that is called the triplet excited state, and the electron, when excited to a triplet excited state, it will be spinning parallel to the original spin. So there are two different excited states. So let's have even closer look at exactly what happens when the electron are excited, and how do they lose their energy in order to get back to their ground state, because they will not stay all the time in the excited state. They have to lose their energy. Let's follow this graph here and see what happens. So let's say this is the ground state, the S naught, and this is the triplet excited state S1, and this is the singlet excited state, which is called S1, and this is the triplet one, which is called T1. Within each of these energy with these different energy level, there are a different vibrationally and rotationally excited rotational and vibrational levels. So the S naught is not only one level, energy level. There are several other levels here, as you see here, different energy levels within the S naught, which are higher than the lowest energy level. These are called vibrational energy levels. The same for S1 and the same for the T1. So these are different vibrational and rotational levels for the excited state as well. So let's say that we have the electron here at the lower energy level of S naught, and it interact with a photon or absorbs a photon, and it gets excited, and it moves from this point along the path A to go to a certain energy level of S1. So it absorbs a light photon with certain energy, with certain wavelengths, and it reaches a certain energy level within S1. This is not the lowest energy level of S1, but at one of the rotational or vibrational energy level. The first thing that happens is that this electron will start to to move back from this higher rotational or vibrational energy level through the R1 path to the lowest vibrational level of S1. As it goes down this vibrational level, it will lose its energy in form of heat. So this is not actually, it doesn't lose it as, or doesn't emit photons. And then what happened? Several things can happen. The first thing is that the electron can move through an energy level with the same energy, but for the ground state, and this is called internal conversion. Internal conversion means the electron will move from a certain energy level to a different one, but with the same energy, from S1 to S naught. So now the electron will be at a higher energy level within the S naught, the ground state, at a higher vibrational level. This is called internal conversion. So there is no loss of energy here because it's the same energy. The both energy level have the same energy. And then this electron, once it reaches this level, it needs to go back to its it needs to go back to the ground state. Or the lowest energy level of the ground state. So it will go through the path R2 here, and it loses all of its energy to reach the lowest energy level of S node. As it does so, it also loses that energy in form of heat, not in form of photons. The other pathway that can happen is that now the electron has went back to its original energy level without emitting any photon. It lost all of its energy via heat. So this is a completely this pathway doesn't emit any photons. Another thing is that when as we go from A again and then to the R1 to reach the lowest energy level of S1, the electron can go through what we call intersystem crossing, and it moves, instead of moving to an energy level of S node or a higher energy level of S node, it will move to a higher energy level of T1, an energy level that has the same energy as the lowest energy level of S1. So this is called intersystem crossing. And then the electron will again lose its energy to go to the lowest energy level of T1, and this is lost by heat. And then as it reaches the lowest energy level of T1, it can again go through a different intersystem crossing, but this time to a higher energy level of S node. And as it reaches this higher vibrational level of S node, which is the same energy of the lowest energy level of T1, it doesn't lose any energy because they both have the same energy. It can again lose its energy by heat through this pathway R4 to reach again the lowest energy level of S node of the ground state. This path again means that the electron lost all the energy it gained, but through heat, not through emission of photons. There are two other pathways that may happen. The first one is when the electron in the lowest energy level of S1 jumps directly from S1 to the lowest energy level of S node. In this case, it will lose its energy through emission of photons, and this is called fluorescence. Fluorescence has a short half-life. The half-life of the fluorescence is 10 to the power minus 8 to 10 to the power minus 4 seconds. So it's very quick. So when it loses its energy, it will then emit photons. On the other hand, also, another pathway, when the electron reaches the lowest energy level of T1, it can jump directly from this level to the lowest energy level of the ground state of its node, and this will lead to emission of photon as well, but this is called phosphorescence. So phosphorescence has a higher or a longer half-life. So its half-life is 10 to the power minus 4 to 10 to the power to up to 100 seconds. So it's longer. The phosphorescence is longer than the fluorescence. So as we said, the molecule, they relax from the S1 or T1 to S node. That happens by emission of by emitting a photon, but it has to be from the lowest energy vibrational level of S1 or T1 to the lowest energy level of S node. The transition from S1 to S node is called fluorescence. Lifetime is quite short. The transition from T1 to S node is called phosphorescence. The lifetime is much longer.